Hello class. For today, I'm going to be talking to you guys about synthetic division and how to solve a polynomial equations or division of polynomial equations. Since we talked about long division, you're going to be finding that the synthetic division way is much easier, and obviously it's something that you prefer. Remember how I told you guys about solving by completing the square? And I taught you guys how to do quadratic formula. And obviously, if I were to ask vast majority of you guys, you would pick quadratic formula over solving by completing the square just because it's that much easier. And synthetic division is pretty much the same thing. I want you to take a look at the first problem here and just look at how much of the work you will have to end up doing by doing the long division. So you would write p to the fourth plus 5p cubed minus 11p squared minus 25p plus 29. Now I'm giving you even quartic functions, believe it or not, instead of giving you cubic like before, and you're going to have to put your divisor over here. Ask yourself how many times can p fit in p to the fourth. You would write p cubed, p fourth plus 6p cubed. Subtract these two, then it will be minus 1p cubed because this would be a minus sign instead. Bring down the minus 11p squared, and so that will be minus 1p squared. Minus 1p cubed minus 6p squared, and convert these both into pluses. This would be minus 5p squared. Bring down the minus 25p, minus 5p. Oh my goodness, this is just so much work. Plus 5p, bring down the plus 29, and then plus 5 here. So that'll be 5p plus 30. Subtract these two, you gotta get a remainder of negative 1. Okay, so my final answer would be p cubed minus 1p squared minus 5p plus 5 minus 1 over p plus 6. Okay? Remember, we put our divisors over, we put our remainders over our divisors like this at the end. But this will be our quotient, and this part will be what we call the remainder. All right, so now what we want to do here is we want to do the same thing, but we're going to be doing something called a synthetic division. Here's what you're going to be doing. Synthetic division is what you're only going to be focusing on the coefficients of the dividend. So here we have p to the 4 plus 5p cubed minus 11p squared minus 25p plus 29. You're gonna just take a look at these five numbers, and you want to write down the numbers accordingly. 1, 5, negative 11, negative 25, and positive 29. And then instead of doing this as a long division, you're going to do synthetic division like this, and give yourself a little bit of a space down here as well, because you're going to be writing down numbers. And you're going to have to put a number here. Now, the number that you put here is super important. It comes from your divisor, and if it says you're dividing by p plus 6, it's basically what you're going to get if you were to solve the divisor with a 0. Okay, so here what you're going to do is p plus 6 equals 0, so then becomes negative 6. So then now you're going to do something called synthetic division. Here's how you're going to do. The first term that you have on the other side of the L shape, you're just going to simply bring this down. Then with these two, negative 6 and 1, you're going to multiply these two and get negative 6. Now 5 with negative 6 is negative 1. Now notice how what you do here with long division is the same essential thing as the synthetic division. Long division, you have to constantly write all of these letters, the variables, along with the coefficients. Whereas the synthetic division, you're only taking a look at the numbers themselves, the coefficients, and going, okay. After that, all I got to do is just write down the letters at the end. So here, if you take a look, the plus 5 and the minus 6, here and here, that's what's happening here and here. And that's why we wanted to find out the 6 as a negative 6, because you know how you're subtracting them. So you put a negative sign there. So anyways, 5 minus 6 is negative 1. So you're always going to be adding these two numbers on this side of the synthetic division. Well, negative 1 times negative 6 gives you positive 7. And once again, with these two, you're just going to simply add them together. Gives you negative 4. Negative 4 times negative 6 is positive 24. So you add them together and get negative 1. Well, negative 1, I'm sorry, did I make a mistake here? Negative 1 minus 11. Minus 11, I think. Oh, there we go. Why did I do that? So this is minus 1 times negative 6, which is positive 6, negative 5, 35, negative 30, negative 1. And now notice how all of these the first four terms here, okay? They're the same exact numbers as coefficients as provided for the long division. And the last number here is always going to be our remainder. So how do we write our final answer with this? Well, the very first term, 1, that's the coefficient in front of p cubed. Now, why is it p cubed? You're dividing p to the fourth by p to the first power. So obviously the very first term has to deal with p to the fourth minus 1. You're only taking 1 away from the exponent. So p cubed, p squared, p to the 1, p to the 0, and this is just the remainder. Now p to the cubed is just p cubed minus 1p squared minus 5p. Anything with the 0 power is just 1, so it's just plus 5, and the remainder you just put that over our divisor. In terms of showing work, it's a lot less compared to this. Okay? Try doing this as a I don't want you to do this as a practice because I want you to think about this for a second. Now, for the synthetic division here, you have 3x minus 1. Now, what does that mean? You still have to solve this for a 0. Plus 1, x is equal to 1/3. Do I have to put a 1/3? Yes, unfortunately you do. So even if they give you something like this, I know that's not really a favorable case, but you will have to end up doing 3, -4, -17, and 6 like this. This is how you would set up a synthetic division. Bring down the 3, and you would multiply integers with, unfortunately, fractions. But sometimes the questions are well designed, so when you do 1/3 times 3, that's 1, -3. -3 times 1/3, that gives you -1. And then you add these two, -18, -6, and look at that, the remainder is 0. So how do we write this as our final answer? 3x squared minus 3x minus 18, 3 times x squared minus x minus 6, and so that will be 3x minus 3x plus 2. So I'm just completely factoring this, but what I'm really interested in is for you guys to be able to do this portion right here. Even if you're given a fraction, like 3x minus 1, and I ask you to solve for the zeros, and I ask you to do synthetic division with it, I will still want you to be able to do that. Okay. All right. Now the question you might ask is, so why not use synthetic division more often? Well, that's because for this reason right here, if you take a look at this problem, x squared minus 1 is equal to 0. Now I have to, you know how you're doing synthetic division, I need to solve for what this number is going to be. Now it's okay if this number is like a binomial where it's like x minus 9, 3x minus 1, 4x plus 2. But what if it turns out to be a quadratic? Like I'm dividing a cubic polynomial with a quadratic. That could certainly happen, and I know that some of you guys might say that this is factorable, but what if it wasn't? You know what I mean? So long division allows us to divide any polynomial anytime. Whatever the type may be, even if you were dividing like x cubic function by, x fourth function by x cubic function, you can still do it because long division should always work. This is going to be a pain in the butt to do, but you can still do it. For synthetic division, something like this is not feasible because I'm only interested in for you to be able to do synthetic division given a binomial term, not like a cubic polynomial for your divisor. So when you're given something that is not a linear term, not linear on denominator, that should be a good indication as to probably do long division instead rather than doing a synthetic division because it's going to not work favorably to your cause. So not every polynomial division can be done through synthetic division. That's what I need you to remember. Pause the video now, and I would like you to try this question on your own. Completely factor each polynomial given a known factor. What are all the zeros of the polynomial? Now, please practice using synthetic division. So now, obviously, I think it's it goes without saying that now synthetic division is going to be much better than long division ever would be. So please use that instead. Pause the video now and then play it again once you're ready. Okay, so the setup is 1, 9, 23, 15. You should put -5. As long as you have this and know how to operate it, I think you're going to be fine. Bring down the very first term always. -5, 4, -23, -15, 0. So this would be x squared plus 4x plus 3. Okay, so how in the world is this x squared plus 4x plus 3? That's because I have an x cubed function dividing by x. So one term, 1 degree less than your whatever you're dividing by. So then this is factorable, x plus 3 times x plus 1. So completely factorization would be x plus 3 times x plus 1 with the first divisor that we have. So my solution would be -3, -1, and -5. Those would be our x-intercepts. So -1, -3, -5, it's going to go through these 3 points. Something I'm going to teach you later, it's going to look like that. Okay, those are the graphs of cubic functions. All right, now try this one. Completely factor each polynomial given a known factor. Please pause the video now and try this one. Okay, so this one is a little bit challenging because it has 2 components. Number 1, you have fraction to deal with. I hope you know what I mean by that. And number 2, you have a missing term. You don't have an x. Just like a long division, you will fill it up with 0. 6, 7, 0, -1. Then you're going to put a -1/2 here. 6, bring down the 6, and then multiply these two, -3, 4. 4 times -1/2 is -2, -2. And then once you multiply those two, it gives you +1, it gives you a 0. Once again, you should have a remainder of 0 because it asks you to completely factor the whole thing. Now this is read as 6 squared plus 4x minus 2. Factor out the 2, I get 3x squared plus 2x minus 1. That's 2 times 3x x plus 1 minus 1. So then my completely factorization along with this would be 2 times 3x minus 1, x plus 1, and then that would be 2x plus 1 here. But notice that if you were to simply do this, if you were to FOIL this out, you do not go back up to here. So I believe the 2 should be canceled out from the whole thing. And the reason for that is because we have a fraction. We have what we call a factor as 2x plus 1. So this number right here as a 2, that takes care of this 2 component right there. So it kind of balances itself and negates itself in a way. But for right now, what you want to remember is that I want you to just completely use the synthetic division to factor it out completely. Even from here, like this to this, if you were to multiply these two together, that's 6x squared times 2x, which gives you 12x cubed. You should understand that something is off. When you have a fraction like this, your equation will change because everything will need to just be canceled by 2 because of this coefficient in the front. Okay? And so at the end of the day, your 3 solutions will be 1/3, -1, and -1/2 when you solve for the zeros. Do not worry about this as much. All I'm interested in is really just solving for the zeros right now using synthetic division. Okay? All right, so your homework problems would all be dealing with this and just synthetic division and solving for the zeros. Tomorrow will be a half day, so I'm going to leave you an asynchronous work. There will be no videos for tomorrow. I hope you have a great day and have a good rest of your day, and I'll see you guys tomorrow.